Hi, I'm Craig Smith, and this is Eye on AI. This week, I speak with Daeil Kim, co-founder of AI.Reverie, the leading synthetic data company for computer vision. Daeil discussed the role of synthetic data in machine learning and his view that synthetic data will become the primary data source for AI training due to its efficiency and ability to eliminate bias. Our conversation was recorded some months ago, and a lot has changed since then. AI.Reverie is now beta testing a self-service platform, which you can access on their website, AI.Reverie.com. I hope you find the conversation as interesting as I did. Why don't you start, Daeil, by introducing yourself, and then I'll ask some questions.
That sounds great. So my name is Daeil Kim. I'm one of the founders of AI.Reverie. AI.Reverie is a startup that was started approximately 4 years ago to solve the problem of training data, which has become a huge bottleneck in computer vision. And so what AI.Reverie does is creates synthetic data from things like a simulation, fully annotated to solve some of the hardest computer vision problems that are out there. And we've created this horizontal platform that allows us to tackle many verticals. This includes things like consumer packaged goods, orbital satellite insights, self-driving cars, across a whole variety of things.
And the system produces already annotated data. Is that right? It doesn't produce raw data that then needs to be annotated.
Exactly. And that's one of the benefits of synthetic data.
How do you work with a client? Do you scan their environment and items and that sort of thing?
It varies a lot, actually, but a lot of times what we'll do is we'll talk with the client and we'll have a few meetings with them before we get started on the work itself, because oftentimes the challenge is very unique. So one example I can talk about is 7-Eleven. There we met with them, discussed their problems. They're trying to build a cashierless shopping system using computer vision similar to Amazon Go. And what we did was we sat with them to discuss what they needed. We discussed what kind of prototype would work, how we're going to prove this out. And we then build that virtual environment using the tools that we've built, proprietary tools that we've built in order to create that quickly. And then we record and capture a lot of that data and deliver that data to them. We're moving more towards a sort of platform-based system where they can collect the data themselves. That's still something we're building. But for now, what we do is we deliver the actual images with all the annotations they need directly to them.
Yeah. And to collect the data on their end, is there any special equipment required, or are they just still images or video?
Oh, it can be both images or video, depending on their needs. Oftentimes, it's a combination of both. And usually we collect the data ourselves, and then we give them the actual big data dump, which could be hundreds of gigabytes. And then they can just take that data and use it for whatever they need.
So let's back up a little bit and talk about training data for AI systems. AI lives on data, but we're talking specifically about supervised learning. And within supervised learning, we're talking about primarily computer vision. You were saying that you collect this data from a client, still images or video as well. Do you do 3D scanning or anything like that?
Yeah, we do everything. So we have our own motion capture studio. We have a whole team of game developers. We have a whole team of procedural artists to help generate worlds procedurally to help speed up the process of world creation. And the only thing we need from the client oftentimes is just a description of what they're trying to look for, maybe some reference images of what they're trying to handle. If they have labeled data, that's even better, because then what we can do is we can then benchmark the synthetic data against their labeled data and see how well it performs, iterate it on a few times until the benchmarks get better, and then deliver it afterwards. So that is often really helpful in terms of working with a client. And that's been a process that's worked well for us. We've been actually working with a lot of really big corporations on this, and there's definitely a lot of computer vision needs on their part that are unique that human labeled data doesn't really solve completely.
Yeah, and that's one of the things I wanted to ask you about. But just on this point, so you talk to 7-Eleven, let's say they want, as you say, an Amazon Go type environment, which needs to track inventory and when something's moved off the shelf. Do you have to do a 3D scan of every SKU, every stock unit?
It depends. It depends on the SKU. So for certain things like bottles that might be shapes that have specific consistent shapes, we might not have to scan everything. We can sort of create textures and place them on them. But certain unique objects, we might have to scan as well. And those are things that it's just sometimes hard to procedurally model sometimes. So we have our own 3D object scanner that can capture new 3D models. And a big part of it is also motion capture. How do people move around and pick things up? It's not that trivial to actually model all the different variations of how people pick things up and put them in a basket and stuff like that. So that's an interesting challenge as well.
So once you have this raw data, then you augment it through video animation or virtual reality, or I'm not sure what the terms are. Can you describe a little bit about that?
Yeah. So a lot of the work that we do is based off the Unreal game engine. So we're actually building almost what is equivalent to a simplified video game, except it's being used to train computer vision. So you can imagine that it's a fully dynamic world. You can walk around in it if you wanted to. You can almost play it like a video game. And as a result, you can capture video, assuming you have the right kinds of animations and behaviors incorporated into that environment. And what's really nice about using a game engine is that so many things are taken care of for you, such as like really sophisticated lighting effects. Unreal came out with RTX support in their latest engine releases, and that's provided really nice lighting effects and photorealism. And it allows a lot of interesting behaviors to be happening dynamically. So you can imagine it's a virtual world, almost like a video game. And then you're just placing cameras wherever you need them and recording or taking still images. Once that's being fed, once the camera captures those images, we have a layer that can automatically annotate it because we understand all the elements within the simulation. What is a person? What is the floor? All of that stuff. And thus we can use that to create perfect ground truth annotations on top of that.
So you're not doing sort of generative adversarial network creations of objects based on your raw data.
Yeah, we do use adversarial systems in different parts. What we found is that with the adversarial creation of 3D models, it's a bit tricky. And this is something we're still looking into and actively developing. But where we use adversarial systems a bit is more in this area called domain adaptation, which is an area of computer vision that tries to, at least in computer vision, tries to take synthetic data and try to make it more like real world data. So you can imagine those neural style transfer algorithms. It has like a sort of similar effect. You have synthetic images, you have real world images, and they don't have to be labeled, but you can transfer the statistical aspects of the real world image into the synthetic image to make it more like the real world image. So we do this adversarial techniques there.
For things like reflections or lighting, is that the sort of thing that would be used?
Yeah,
for?
textures across objects that often affects, and also sensor noise as well. There might be unique characteristics of the sensor that is just hard to model with synthetic data, and it might just be easier to capture that using domain adaptation techniques.
And then once you have ingested the raw data and built the world that you want to build, is it just a matter of compute to generate more and more data?
Yeah, the hard part, it's funny, it's a different kind of labor that is upfront. There's more labor in terms of creating the environment, of course. But once you have the environment, then all the other problems are pretty much solved. You can just keep generating as much data as you want, change the camera angle, change the lighting, incorporate new scenarios, do all of that stuff that allows you to create that diversity. For us, our belief is that synthetic data has a huge advantage over real world data on several aspects. We think it's complementary. So the future AI stack for computer vision will require synthetic data in order for the field to progress.
And why is that? Just because of the volume required?
It's because certain types of data, collecting certain types of data can be very difficult. So for example, an edge case, right, that rarely happens in the real world, but needs to be accounted for. You can simulate that in a synthetic environment. Right. And this is often used in self-driving cars with particular scenarios. It's also very scale efficient in terms of the annotations. So right now, if we're just thinking about bounding boxes, right, it's a pretty simple annotation task. And then you move on to segmentation masks, which are a bit more complicated. And these are like working on a coloring book, but it takes more time. Now imagine you want to start annotating activity across video frames. And if we're still assuming supervised learning is something that people are still doing 10 years from now, then that annotation process is actually going to be completely laborious for almost anyone to do by hand. And there's going to be a lot of errors. So that is why I look at this kind of current standard of labeling data using humans in the loop. There's going to be a point in which it becomes too expensive in order to get more sophisticated inferences from computer vision algorithms.
I mean, there are ways of augmenting data without creating synthetic data, right?
Rotations, transformations,
yeah, exactly,
color corrections, things like that. Yeah, but just annotating one video with like 20 frames per second, and let's say you want to annotate their pose and then put a label as to their intent of their activity, it's so expensive. I mean, the quotes I'm hearing from other companies and the reasons why they're working with us is because even at major corporations, they don't have the budget to spend the hundreds of thousands of dollars to actually get a few videos annotated. So I just don't see, I actually think because of the cost, it's actually limiting the progress of computer vision.
Are there drawbacks to synthetic data?
Oh, absolutely. There's drawbacks, but the only drawback I would say is the gap between synthetic and real. So if you can solve that, then synthetic data can be used for everything. And so at AI.Reverie, what we're really focused on is actually what we found to push the needle more is not so much photorealism, but more on diversity. So this is why a big part of our platform and our tools that we build is around proceduralism and being able to create hundreds of variants of buildings, hundreds of variants of roads, hundreds of variants of street lamps, things like that. That is really important when it comes to getting high quality synthetic data. And then from there, you can layer on all sorts of interesting things to make it more complex. But that's the thing that we're really focused on. And the way I look at it now is that you can think of a lot of the AI challenges as sort of narrow AI problems, all the way to very not so narrow general AI problems. And a narrow AI problem might be just sort of looking at a conveyor belt and seeing goods coming out of that and sort of being able to measure their size or segmenting them out as they come and counting them. Those problems can pretty much be solved almost entirely with synthetic data, actually. What we found in terms of our performance that you pretty much get 99% of the performance of the real world data when it comes to those narrow problems. And that's encouraging because it shows that it can work. It's something that is very powerful. It's orders of magnitude cheaper, and you can scale the diversity in a controllable way that it's kind of hard to do in the real world. Now, as you start getting into the self-driving car and the more general problems, what we're finding is that synthetic data, at least in terms of the data that we're generating, gets to about 70% of the real world data performance. But that gap actually can be driven down even further and go up to something like 95% of the real world data when we do things like transfer learning, fine tuning with just 10% of that real world data. So in supervised learning, you have your train, validation, test set, right? If we just take 10% of the training data set and use the rest with synthetic data, it can actually get up to 95% or more, sometimes even better than the real world data performance. So I think there is a real need to look at synthetic data as a serious alternative to real world data. I'm not saying that real world data isn't going to play a role, but I do see a future where synthetic data becomes a primary source to train an algorithm. And real world data is primarily used to benchmark or fine tune. And then that will drive costs and help accelerate the field.
And just on that gap, can you define that gap and give a concrete example? Is it in resolution?
Sure. We actually published a paper on this called Rare Planes. It's on the archive, so you can find it, and I'll share the link later. But the challenge was to detect planes from an orbital satellite across various airports. And this was in a collaboration with Cosmic Labs, which is part of In-Q-Tel. And they actually went and bought a whole bunch of real world satellite imagery data and got it labeled and all that stuff. And then we created our own synthetic data set and compared it there. So that was an example where we got 70% of the performance of real world data because the scenes are a bit more complex there. And the nuances and the differences, it's still a challenging research area to figure out exactly what those differences are, right, in terms of the real world data and the synthetic data. But some of the things we notice is that the synthetic networks will often look at different parts of the airplane than the real world data for its performance, right? And then so some of the things that the synthetic data didn't account for are often things that we just didn't actually have as much support for. Real world data had a ton of these snowy environments, and the shadows are really particular there. And those are often the cases where we got them wrong. But I think if we spent enough time working on those kinds of environments and refining that, we could have done much better. But it was actually really the edge cases there in the real world that we didn't account for. But it's iterative process, right? It's hard to get it all right the first time.
And presumably, if you are able to do that analysis, you can then correct for that in the synthetic data and do another analysis. Is that what you were talking about, closing that gap?
Yeah, what we do is we actually have all this sort of virtuous cycle where we first create the synthetic data, we benchmark it, and then we look at where the differences are between real world and synthetic data. And then we keep iterating on the synthetic data and then benchmark it over and over and over again until we get to the performance we're happy with. Of course, that's a function of how much time and resources we have. But I do think that that could be a future model for how we actually improve computer vision algorithms, where we actually just take the real world data and only use it to test things. And then we just keep trying to improve the synthetic data to account for those differences.
Can you talk about the Unreal Game Engine? That's an off-the-shelf product. And where is your effort in doing this? Or where are the resources spent? Is it in compute? Is it in human design, or is it in the original data collection?
Yeah, so most of the time is spent probably in the content generation aspect, right? Being able to create the worlds that we need in order to support the problems that they're trying to solve. And what we've been doing as a way to help accelerate that process is basically building a lot of tools that fit certain verticals. So a conveyor belt for consumer packaged goods, there are general systems that we can build to ensure that if we take on another task, those same processes and same virtual content generation tools could be used again. We have a system that can ingest geospatial data and then be able to create large open world maps that are fully walkable, like New York City, for example. And we can generate that now in a few days by ingesting all this and creating procedural buildings and roads, things like that. So a lot of our time is spent on creating those tools that we then apply to solve some of the challenges. The airports data that we have, we actually publicly share that along with the paper. The airports, they're all procedural buildings. They weren't crafted by people. The lanes, the runways, all that stuff was all procedurally generated geometry.
Meaning that it reflects data that you collected from imagery or maps?
Yeah, we use things like OpenStreetMap, we use satellite images, we use as much metadata as we can to help accelerate those efforts.
So how much of the synthetic data that you're producing is handcrafted?
It's hard to say, depends on the problem itself in terms of the vertical challenge. But let's say we're designing things like a conveyor belt, consumer packaged good, where items are coming out. That might be completely procedural in terms of the items themselves, but the conveyor belt itself might be something we place by hand, you know? So there's different aspects of it around it, but I can give you a rough time estimate. It usually is between 3 to 4 weeks after we talk with a client that it takes us to get to the initial prototype. And then once we have that system built, it's every week or two, we can iterate and improve upon it. And I think this is a far more efficient timescale than the typical collecting the data in the real world, getting people to annotate it. Once they annotate it, using in-house staff to check for errors, and then iterating back and forth again.
Well, why then do you say that there's still a role for hand-collected, hand-annotated, or human-annotated data? Why, other than this gap, but as you say, you can work on closing the gap, why would anyone want to spend the time and money it takes to hand annotate, particularly video?
I would say that in the future, right now, it's important because real world data at the end of the day is the ultimate gold benchmark. So if you have labeled data, it acts as a great benchmark for synthetic data, and it can also aid in fine tuning. But I will say as of today, I think there's way more hand labeled data than necessary if you are going to work with synthetic data. So I think you can actually reduce your budget by 80 to 90% if you're willing to go with synthetic data to some degree. And that's why I'm trying to evangelize the importance of this and why this needs to be the future paradigm. I do see in the future that real world data might only be used to benchmark how good is the synthetic data, right? At the end of the day, and then be able to iterate more quickly on it. Another really cool thing, the way we've built our worlds is that it's very driven by API. So we can make API calls to the virtual environment to change the weather, to change certain behaviors. to spawn more things, to spawn less things, change entire biomes. And what's cool about having this system be connected via a set of APIs is that in the future, you can imagine the real world data set acting as the benchmark, and the let's say the mean average precision scores you get from that can actually be fed into a reinforcement learning algorithm, where the RL algorithm actually then drives the diversity in the virtual environment, right? So that this whole thing can be kind of a self-contained system at some point, if you can imagine that.
And when you say drive diversity, you would just set a reward for the number of kinds of plants or the number of...
Or reward for just increasing mean average precision. It could potentially drive less diversity, but it would sort of explore and exploit the parameters of the API space to know how to create the right kind of data. I see that as a very, very powerful system that I hope we can work towards. I don't think we're there yet, but we're getting close.
There are a lot of platforms and BPOs out there that are labeling as a service. Are you working with any of them as opposed to working directly with clients? Presumably, they don't have this capability, but they could offer it to their clients. Instead of labeling 100% of your data, we'll hand label 10% and then plug in AI.Reverie. Have you talked about those kinds of partnerships?
Yeah, there's two things. One is that when we talk with customers, they're often coming to us because they don't want to spend all their money on labeled data. And they basically want to be able to try synthetic data out first. And they often have labeled data already, right? They've already spent the tens of thousands of dollars labeling the data, and they're kind of feeling, how much more can I spend on this data set, right? So I do believe it's complementary, and I'd love to work with other companies that are labeling data, but I do also think that we represent a kind of, not an antagonistic threat, but we are disruptive, right? If we're basically saying that the cost of a fully annotated image at the end of the day of any kind of annotation you want is basically the GPU cost to produce it, you know, that's a sub 1 cent, right? And they're charging $6 for a segmentation image or something like that, right? So it's, I think, difficult to establish that.
It would be more the other way, that you guys would add a human annotation team to sort of do the ground truth and then synthesize on top of that. There is a lot of talk that annotated data will eventually go away or become less important as other forms of machine learning improve. Are you concerned about that at all?
Are you talking about some of these unsupervised approaches and being able to automatically assess? Yeah, I think we're still a bit away from that. And I would also argue that in the future, well, let me put it this way. Supervised learning works because if you think about it, it's the easiest thing to do in some ways, right? You're learning a mapping from A to B. Right. And with unsupervised learning, there's a lot more model architecture and thought you have to put into maybe something that hopefully works well. What I like about synthetic data and simulation is the control you have, right, in terms of creating that data and how you want to create it. I don't know how much control I would get from an adversarial based approach or an unsupervised approach in terms of exactly defining what I need from an algorithm. In some ways, I think of synthetic data and the supervised learning approach with synthetic data as a really, really effective way of making sure we create algorithms the way we want to create that, if that makes sense.
One of the challenges in supervised learning are biased or imbalanced data sets or corrupted data sets. Is one of the things that synthetic data can do or could do is to find corner cases or underrepresented classes in data sets and then balance the data. Just thinking about women and minorities is a big problem because oftentimes data set scraped from the internet and are not balanced. So yeah, can you talk about that a little bit?
Yeah, absolutely. That is a big problem with real world data. If you look at OpenAI's new GCP algorithm, it reflects biases that exist in society, racial and gender biases. And those things can be mitigated with synthetic data. And that's another aspect of synthetic data, why it's so valuable. It can deal with edge cases, corner cases. It can help balance a data set when it doesn't contain all of the attributes necessary for a generalizable algorithm. You have full control, right? And this is back to the first point. You have control over what you want to create. And the design of the environment itself then reflects what the algorithm will do versus just relying on the data in the real world and assuming that that's enough to get the algorithm to perform a certain way, right? So rather than focusing on the architecture of the algorithm to ensure that those biases don't exist, you can now just focus on the data, and it becomes a different way of actually training algorithms in the future, where now it's not so much about iterating on architectures or figuring out layers or things like that, or do I use this transformer here? It can just be, I'm going to modify the data, and that is what the algorithm will ultimately become.
That's interesting.
I'd like to add one other thing about the annotations as well. With some of the clients we're working with, some of the annotations that they ask for can't actually be done by humans. So let's say you're putting products down a conveyor belt. They might want to know things like the volume and mass of that object, right? And how would a human be able to annotate that by looking at an image? Or they might want things that are actually occluded, and they want to know what the underlying occlusions look like. How would a human know, right? What the underlying things are there. So I just want to point that out, that that's another benefit of it as well.
What sort of penetration is there today in the world of supervised computer vision with synthetic data?
Well, when we started about 3.5, 4 years ago, it was a desert a little bit, right? We had to explain to them what it even was for many companies. And some people sort of knew about it. I think the landscape has changed a bit now. And now there's more of an understanding of the value and benefit of synthetic data. I think we're definitely in a different landscape that's more receptive to us. So we're glad about that. And part of it is also proving it out, right? So a lot of things that we had to do was initially prove that synthetic data worked and release papers, give people data sets, do benchmarks, all of that stuff. And I always believed in it, but it's another thing when you're trying to sell that to a company to spend money on it. So I think it's changed a bit. And I think in the next few years, I think it's going to be even stronger. So I really think there's a space there. But computer vision in and of itself, in terms of the vast field of AI, there's a lot of companies that are still trying to build computer vision teams as well. So there's still ways to go. It's not as mature as something like relevance, for example, or something in NLP or other types of fields where you might be able to have a lot of penetration in that, a huge market share of, for example, receipt analysis. That's an area a lot of people are, spending a lot of time and money in. So it's still growing, basically.
And something like receipt analysis, you could obviously do that. That would be a simple problem for synthetic data, I would guess.
Yeah, we can certainly create all sorts of variations of forms if need be. Yeah, there's a lot we can do there. Yeah.
What's the most complex implementation or complex data set that you've worked on?
I would say urban scenes are pretty complex. There's a lot that goes on in an urban scene that is hard to simulate every aspect of. So there, the diversity problem is really hard. Satellite images, anything that is a really large open world kind of place is going to be much harder. And I just think of that as how diverse are the things you see in there and how many different kinds of scenarios and complex interactions can occur in a space. When we worked on certain problems in urban areas, we found that that was the hardest thing to simulate correctly.
And what kind of customers are looking for that kind of data?
The customers that are interested in autonomous vehicles, autonomous robots that actually will walk around and do things. I can't talk about the company we're working with for NDA reasons, but I can perhaps say that navigating an autonomous robot from one sidewalk to another is a very hard problem, right? You have to know, for example, where the sidewalk ends and where the road starts, right? And that's like an existential problem. If you can't know that, then off it goes into the street with a don't walk sign. So
yeah, that's interesting. Is there a lot of competition in this space?
We do not see a lot. In terms of every customer we've worked with have not said they used another company or talked to another company. And we've had a lot of repeat customers and they've never been, oh, how about this company? Can we work with more? You know what I mean? We've literally never heard of other companies' names pop up. And I know other companies exist, right? I know other synthetic data companies exist, but I think they're also starting off in an earlier stage. And we've been around for 4 years, so we've seen a lot of what's happening. So I think the market's still quite large in that sense. There's a lot of opportunities still, So we're excited about that. And we're excited about the sort of head start we have.
Yeah, yeah. I've spoken quite a bit to Julian Togelius. I don't know if you know him. He's a professor at NYU and it works a lot in video games and virtual world generation and game level generation, that sort of thing. And particularly with the Unreal game engine. How high is the barrier to entry? Because there's certainly a lot of people in the video game industry, a lot of people familiar with Unreal game engine. There are a lot of people in research institutes working on these generative processes. Are you concerned about that at all? People will start seeing this as an opportunity.
The Unreal Game Engine has a rich game developer ecosystem, but game developers focus on different things, actually. And for us, we often have to realign a game developer to sort of ensure that they understand what they need to do when it comes to synthetic data for computer vision. So for us, it's not as important that the AI has to move exactly a certain way, or there isn't like text or narrative as much in what we do versus a video game developer who's really focused on the whole narrative aspect of a video game and isn't concerned about maybe diversity as much, right? As much as there are bugs when it comes to stepping on water or things like that. So the concerns are often very different because what we really focus on is just trying to create as much diversity. And it doesn't have to be narrative at all.
I'm interested in storage of label data because we're really at the beginning, even if other forms of machine learning overtake supervised learning in 10 or 15, 20 years. Between now and then, the volume of label data is mushrooming. And all of that data has to be stored somewhere. I mean, people don't spend all that money labeling data and then extinguish it. Can you talk a little bit about the storage? And in this case, with virtual data, is it possible that you can spin up the data since it's being generated and then get rid of it? And then if you need it again, you already have the algorithms in place to spin it up again. I mean, do you need to store it in the way that you need to store hand labeled data?
Well, in the future, when we go into the sort of meta sim world, right, then it just becomes a matter of running the environment in an online learning process. And then you just keep training the algorithm directly from the images that come out of the simulation. So this idea of using images and labeling them is really a consequence of just what we have as a technology. We can take pictures with cameras and then we can then train an algorithm on the 2D image. But in the future, the 3D environment stores so much more information. So to your point, the future is just storing the virtual environment versus actually storing the images and creating unnecessary duplicates of something that comes out of the same place.
Meta sim.
Meta simulation. The paper called Meta Sim came out a few years ago that talked about this idea of using RL to modify a virtual environment. So I'm referencing that idea.
And another question that I've pondered, all of this labeled data, whether it's hand labeled or synthetic, as all of this labeled data builds up in these massive data lakes or whatever you want to call them, along with all of this synthetic data, I would expect that there are enough common use cases that there'll develop markets for labeled data. So instead of having to create more labeled data, you find a data set that matches your use case and you license it or something like that. Do you see that as part of the future?
Yeah, we thought about this too, like whether we sell data bundles and things like that. What we've found though is that people's configuration of their cameras in terms of their smart cameras are pretty specific. And so if you don't get the right perspective, for example, on a deep learning algorithm, you can really bias your algorithm in the wrong way, right? So being able to model the sort of real world sensor noise and distortion that exists is kind of important as well. So these things play a role there. The challenge with selling data bundles is that it might not be as effective in terms of getting to mission critical performance, but it can certainly help. At least we're used to training neural networks on ImageNet, right? Just pre-training it. But there are papers that show that actually pre-training on synthetic data is much more effective in actually getting a better algorithm out of it.
So you could have bundle data sets for pre-training. Is that right?
Yes.
And can you give a concrete example when you said that sometimes the sensor noise is important? What are you talking about there?
For example, distortion, and then there's noise within the camera itself. So it might pick up certain kinds of artifacts that you just don't get in the synthetic data, because there's things with the lens and the camera sensor itself that affect the actual image quality, right? So if you're looking at a camera that, let's say, might be, I'll just take an example of a robot vacuum, right? That's a very funky camera, right? And the way it looks and the distortion it provides. And then there might be other aspects of the camera where it's picking up, light artifacts and things like that your synthetic data doesn't have, that might be an important part of it. So these are things that I think would cause potential issues if you're only relying on synthetic data.
As all of this data accumulates, and it's really only started, there's going to be oceans of this labeled data. Algorithms are increasingly general, or that's the goal, to make them increasingly general. Right now, they're very domain specific. I mean, that's a very good example on the noise that's specific to a particular camera. Then you would need data that matches that in order to train a system that's using a live feed from that camera accurately. But as algorithms generalize, will there come a day that all of these pools of data will merge together and algorithms will be able to crawl through and train on the existing data in the world and do something useful? In other words, instead of having to create a tailored data set for this particular system, you can create a system and turn it loose on massive data sets, and it would train to a certain level on its own on existing data.
Right. So maybe like the equivalent of OpenAI's GPT-3. I mean, this network has like 175 billion parameters, right? And it's basically mined through like every possible text out there. And it does remarkable things as a result of that. So I definitely think that you could at one day have a vision algorithm capable of being robust to a lot of different things. I do think there's significant differences between vision and language, because in terms of vision, you're also dealing with the hardware aspect of the camera itself, right? So depending on how the camera looks at the image, it can oftentimes warp things. And maybe this is where, like you have with GPT-3, you can fine tune it with a certain kind of camera, and then everything works. But I do believe that synthetic data actually is what I would think of as the only real way to control the prior on a neural network, So when we think about priors and Bayesian priors or things like that, or how do you give a prior belief to a neural network, I think synthetic data is going to be a wonderful way of doing that. And at some point, the hope is if we create enough virtual worlds, enough virtual environments, we might be able to then do it on that level. And I think the scaling of the simulation is going to be easier than scaling of all that data. Because, the data sets, when it comes to vision data sets, it's a lot harder to mine them and get the right annotations for them as well. We'll see 10, 15 years from now, or even earlier, we might have the equivalent of the GPT-3 vision. But for now, it doesn't seem like that's easy to do.
And so what are you working on now beyond servicing clients? What sort of research are you doing? What's the next step in your system?
Yeah, so the big focus we have right now is bridging that domain gap at the end of the day. So the two things we're focusing on is how do we create better domain adaptation algorithms? And then how do we think about ways of accentuating the differences between a synthetically trained network and a real world benchmark? So by that, I mean, how do we have interesting ways of figuring out where the algorithm is looking at those things? There's a recent paper from Facebook called the Dieter model, where they can actually analyze the layers of the transformer architecture to create spatial attention maps, right? To sort of understand where an algorithm is focusing on. So being able to create better things there, better tools, better algorithms, and also pushing the boundaries on domain adaptation is a big R&D thing that we're constantly focusing on. Because once we bridge that gap, all the benefits of synthetic data come into play over real world data. So that's where we're really focusing our energy.
That's it for this week's episode. I want to thank Daeil for his time. If you want to know more about what we talked about today, check out AI.Reverie's self-service platform at AI.Reverie.com. And remember, the singularity may not be near, but AI is about to change your world, so pay attention.